Okay, then we are recording ourselves instead of via Zoom. Should work the same. Okay, hello everyone. My name is Andreas Arnason and I teach here at BTH, but I'm mainly teaching courses that revolve around web development. So I have a couple of Python courses, and then I have another course that's just about DevOps and the tools of what that is. So today I'm going to try to explain briefly what is DevOps. You can delve down quite deep if you want to, but we don't have the time for that, so I'm going to give a broad overview of what DevOps is. So a lot of people, when they think about DevOps, they think a lot about the specific tools that are used. So if you use tools like Ansible or a continuous integration chain like CircleCI, then you're doing DevOps work. But that's not what I'm going to talk about today, because that's not really DevOps, that's just a tool. The point of DevOps is more about how do we use these common and popular tools to create a effective work environment, basically. So that's more what I'm going to talk about, a theoretical overview and workplace, something like that. And then on, I think it's Wednesday, we're going to have a lecture by a guy named Igor. He will talk more about tools and pipelines and stuff like that, more the cool stuff. So, what is DevOps? DevOps is a way of thinking and a way of working, not just using tools. It's a framework for sharing stories and developing empathy, enabling people and teams to practice their craft in effective and lasting ways. So a lot of this talk is from the book, the Devops Handbook. It's a good book that tries to explain DevOps. So one of the problems with DevOps is that it's not, you can't point to one definition of DevOps and say that is what DevOps is. A lot of people have different ideas of what DevOps is, and also corporations need to create their own version of DevOps and make that work for their company. So what I'm saying today is not this is DevOps, it's more of a general idea of how we can achieve some kind of DevOps workplace. But the book, the Devops Handbook, it have a quote where they try to quickly define what DevOps is. So they say, DevOps is a manifestation of creating dynamic learning organizations that continually reinforce high-trust cultural norms. We can also see it as applying lean principles to the technology value stream. So I assume most of you who are watching this at least know about lean and agile work methods. That's been very popular last 15 to 20 years. I'm going to talk a little bit about this in this lecture, but I'm not going to explain it really what it is, because I assume you already kind of know that. But we can see DevOps as the next step of that movement that happened some years ago, and now DevOps is the new movement that kind of builds on what was done before. So how can this manifest in real life, or how does it look when a company actually works according to DevOps? So in software development, there are a few common players that are usually there in the organization. So we have product owners, architects, developers, quality assurance, IT operations, information security, and database operations people. So the point of DevOps is that they should all work together to help each other and ensure that the overall organization succeeds. So they should have a common goal that they're working towards together by enabling fast flow of planned work into production, like performing tens or hundreds or even thousands code deployments per day. while at the same time achieving reliability, stability, availability, and security in the production environment. And with production environment, we're not only talking about the one people commonly speak about, which is the customer environment that their customers are using. It's also important to acknowledge the environment that you work in, your own development environments and your staging and testing environments. They should also be kind of the production environment because they are part of everything that's important. One way to then work DevOps is to have cross-functional teams that rigorously test their hypotheses of which features will most delight users and advance the organizational goals. They care not just about implementing user features, but also actively ensuring that their work flows smoothly and frequently through the entire value stream without causing chaos and disruption to IT operations or any other internal or external customer. So quality assurance, IT operations, InfoSec, database, always working on ways to reduce friction for the developer team, creating work systems that enable developers to be more productive and get better outcomes. By adding the expertise of quality, IT, InfoSec into delivery teams and automated self-service tools, and platform teams are able to use expertise in their work without being dependent on other teams. So this enables organizations to create a safer system of work where small teams are able to quickly and independently develop, test, and deploy code and value to maximize developer productivity and enable organizational learnings, create high employee satisfaction, and win in the marketplace. The presentation program went a little haywire. So, enough sales talk. What does it actually mean for you as perhaps a developer to work at a company where they work according to DevOps? So we can take a look at an example of the website called etsy.com. I'm guessing perhaps some of you know of it. It's a big website where people can say, hello, I have made this, I want to sell this. So it's a big marketplace, basically. And the company that makes the website are very big in DevOps. They have speak a lot on conferences and create tools that they share, open source and stuff like that. So we can take the example of what it's like to become a new developer at Etsy, how it's like to be a new hire there. So when you're new, you start your first day at the job, then you get a laptop which already has a development virtual machine set up on it. The virtual machine and all the tools are set up using configuration management tools, and you want that environment to be as similar as possible to the continuous integration, production environment, and all your other colleagues' environments. So you don't want the employees' different laptops to be different from each other. They should be as similar as possible to them and the environment around them. And this should all be done using code to minimize the possibility of changing in the environment. So the laptop has already accounts for accessing everything. They have GitHub repos clone, they have aliases, shortcuts, tools, everything is already set up on the computer. So the new hire should be able to just sit down and start coding on the first day. They also get a current employee that already works there to pair them as their mentor to talk them through what it's like to create code there and how the testing is done. On the first day, the new employee will start writing code on the local virtual machine. Then they will try and run it, and they will run the tests on it just to make sure that everything passes the test, so then they can be more secure that the changes in their code can work for everyone else at the company and in the production environment. So the first day when they write their code, they run the tests, and then they push the test to something called a try server, which is outside a version control like Git or stuff like that. So they want to be separate. They don't want to take new changes and put it inside the GitHub repo before they know it actually works. So the try server is big Jenkins cluster where they run more tests on it, and if those tests pass, then they move on and add the change to something called a push queue. So they have a giant push queue for all the developers at Etsy, so what they do then can one at a time get to take their code and move it on to the next step in the deployment pipeline. So when it's the new hire's turn in the push queue, then it activates something called the deployinator. And that bot or tool, or what we want to call it, automatically takes her latest commit that was done and pushes it to quality assurance and starts the continuous integration tests on the change. And if all those tests pass, the deployinator then the new hire has to look for all the logs of the tests and look at the logs on the machines just to make sure that the test didn't miss anything. And if everything looks good, they activate the deployinator again, and then the deployinator takes the change and adds and runs it on the live production servers. So on the first day of a new hire, they actually get to write code, run tests, and deploy it to the production servers. Because Etsy, they have a what we call it, a high trust working environment where they believe that if you are hired by them, then they expect you to have the knowledge of what you are hired for. So they trust in you being knowledgeable in your area. So this process of being done developing and being ready to push your changes only takes about 10 minutes on average. So a few years ago, Etsy, they deployed around 60 times a day. That's quite a lot, and this is a few years ago, so I believe they push even more often to development per day or to production nowadays. And they don't they don't have mandatory code reviews for changes, so it's up to each developer to know that, okay, what have I done? Do I need other people to look at the change in the code to see if we can find some more errors, or was it such a small change that that's not needed and we can go directly to the test and the deployment production environment. So that's also a big part of DevOps, trust from your bosses and trust to your colleagues that they know what they are working with. Let's get back to the DevOps concept. So why is DevOps needed, or why DevOps perform well compared to other ways of working according to the Devops Handbook? This is because corporations are not able to resolve a core chronic conflict within their technology organizations. In most IT organizations, there is an inherent conflict between developers and IT operations, which in turn creates a downward spiral resulting in ever slower time to market for new products and features, reduced quality, increased outages, and ever-increasing amount of technical debt. And this is often caused by competing goals between the developers and IT operations. IT organizations are usually responsible for many things, and among them are the following goals: respond to rapidly changing competitive landscape and provide stable, reliable, and secure service for customer. So the developers, they will try to respond to the market and add as much new functionality as possible to production, while IT operations try to provide a stable, reliable, and secure experience for the customers, which can make them negative to add more changes to the production environment, because that can easily risk their goals. So when we have goals configured this way, developers and IT operations are opposed each other in goals and incentives of what they should do at work. And this is the core chronic conflict according to Dr. M. Goldratt, when organizational measurements and incentives across different silos prevent the achievement of global organizational goals. And this conflict creates a downward spiral which prevents the achievement of desired business goals both inside and outside the IT organization. So the result of this downward spiral is poor software and service quality and bad customer outcomes, as well as daily need for workarounds, firefighting, both in production management, developers, quality, IT operations, and InfoSec. So everyone is fighting a constant battle of trying to make things better. So what are these 3 acts then? The first act begins in operations, where the goal is to keep applications and infrastructure running so they can deliver value to the customer. Their problems are caused by complex, poorly documented and fragile applications and infrastructure. This is the technical debt and daily workarounds that they live with every day, promising that they will fix the mess when they have a little more time. But that time just never comes. So when these systems fail, they jeopardize the most important organizational promise, such as availability to customers, revenue goals, and security of customer data, and so forth. Then we come to the second act, which begins when somebody has to compensate for the latest broken promises. It could be a production manager promising bigger, bolder features, or a business executive setting an even larger revenue goal. Oblivious to what the technology can or cannot do, or what factors led to missing the earlier commitment, they commit the technology organization to deliver new promises. As a result, the developers are tasked with another urgent project that requires solving new technical challenges and cutting corners, further adding to the technical debt. Made with the promise that it will be fixed when we have more time. So things go wrong, we don't have time to fix it. Someone promises we'll make something even cooler, while we still have the problems from before, which just adds more technical debt and code on everything, which just makes it worse. And this takes us to the third act. Everything becomes a little more difficult. Bit by bit, everyone gets a little busier. Work takes a little more time, communication gets slower, and work queues goes longer. Smaller actions cause bigger failures, and systems get less tolerant of making changes. Work requires more communication, coordination, and approvals. Team must wait longer for dependent work to get done. You can say the wheel begin grinding slower and require more effort to keep turning. And as a result, production delivery cycles are slower, fewer projects are started, and we can no longer keep up with the change in market landscape and lose marketplace. And once again, we will learn that when IT organization fails, entire organizations fails. So how do we break the downward spiral with DevOps? What we want is small teams of developers independently implement their features, validate their correctness in production-like environments, and have their code deployed to production quickly, safely, and securely. Code deployments are routine and replicable. They happen all week throughout the business days without the customers even noticing that it has happened. We have fast feedback loops at every step of the process. Everyone can immediately see the effect of their actions. Using automated testing helps developers discover mistakes quickly. We have production telemetry in both our code and production environments to ensure that when problems arise, we can quickly detect them and then correct them. High-profile product and feature releases are done with dark launch techniques. Long before the launch date, the code is put into production, invisible for everyone except internal employees and a small cohort of real users that just test it for us. So dark launch deployment is about how do we get code into production environments without disrupting or the customers noticing, and then when we feel sure that things are working with the new code, and we just flip a switch and suddenly the customers are using the new code. With every fix we make, we generate organizational learnings, enabling us to prevent the problem from occurring again and detect similar problems faster. Everyone is constantly learning, fostering a hypothesis-driven culture where everything is measured and development is handled as experiments. Instead of a culture of fear, we have a high-trust, collaborative culture where people are rewarded for taking risks. Employees are able to fearlessly talk about problems as opposed to hiding them, because we must see problems in order to solve them. Because everyone fully owns the quality of their work, everyone builds automated testing into daily work and use peer reviews to gain confidence that problems are found long before customers can be impacted. When something goes wrong, we conduct a blameless postmortem, not to punish, but to understand and learn what caused the accident and how we can prevent it from happening again. And this is how the DevOps concept see many problems in IT and then how we can fix them. So let's take a short sidestep and talk about the history of DevOps, so where it comes from and what it builds upon. So DevOps is a result from a broad stroke of movements phenomenon described by John Wills as the convergence of DevOps. There are decades of lessons learned from manufacturing, high reliability organizations, high trust management models, and other that has brought us DevOps today. So DevOps rely a lot from knowledge about the lean movement, theory of constraints, and then the Toyota production systems, but there are many more. So while the foundation of DevOps can be seen as derived from lean, the theory of constraints, and the Toyota Kata movement, many also see DevOps as the logical continuation of the Agile software journey that began in 2001. So Agile and Lean is a lot about the process of how we handle customers, their requests, and how we take what the customer wants, make it into requirements, and then make the developers develop that functionality. But the journey kind of stopped here of the developers. So the Agile and Lean, it was, okay, how do we go from customers to developing something? And then DevOps is the continuation from there. Okay, now we want to also include what happens after something has been developed and put into code, and how it's a journey to the production environment, to the customer, back. So that's how we can see the journey to where we are today. So from the Lean movement, we got techniques such as the value stream mapping, Kanban boards, and lead time. Lean has its roots in the Toyota production system in the 1980s. Lean principles focus on how to create value for the customer by creating constancy of purpose, embracing scientific thinking, creating flow and pull, and ensuring quality at the source, leading with humility and respecting every individual. So here it's a lot about a good and safe work environment, which is very important in DevOps as well. Then we have the Agile Manifesto, which was created in 2001. But he wanted to create a lightweight set of values and principles against the heavyweight software development process, such as waterfall development. One key principle was to deliver working software frequently, from a couple of weeks to a couple of months, with a preference for the shorter timescale. They wanted small batch sizes, incremental release instead of large waterfall, small self-motivating teams working in a high-trust management model. Many of the key moments in DevOps history has historically occurred within the Agile community or Agile conferences. Then we have the continuous delivery movement, building upon the development discipline of the continuous build, test, and integration. Jess Humble and David Farley extended the concept to continuous delivery. This defined the role of a deployment pipeline to ensure that code and infrastructure are always in a deployable state, that all code that is checked in can be safely deployed into production. And this was presented at 2006 Agile conference. So it's how can we always make sure that new code and new features before they are put into production, how to make sure that they are ready to be put in production environment at all times. And in 2009, a guy named Mike Rofer wrote the Toyota Kata, Managing People for Improvement, Adaptiveness, and Superior Results. This framed his 20-year journey to understand and codify the Toyota production systems. He was one of the people who helped develop the Lean toolkit, but he was puzzled when none of the companies adopting these practices managed to replicate the level of performance observed at the Toyota manufacturing plants. He concluded that the lean community missed the most important practices, the improvement kata. Every organization has work routines, and the improvement kata requires creating structure for the daily habitual practice of improving work, because daily practice is what improves outcomes. The constant cycle of establishing desired future states, setting weekly target outcome, and the continual improvement of daily work is what guided improvement at Toyota. These are some of the historical movements that DevOps drew upon. So in 2008, at an Agile conference in Toronto, Canada, a guy named Patrick Dubois and Andrew Schaefer held a birds of a feather session on applying Agile principles to infrastructure as opposed to application code. In 2009, at the Velocity conference, John Alspo and Paul Hammond gave the presentation 10 deploys per day, Dev and Ops cooperating at Flickr, where they described how they created shared goals between developers and operations and used continuous integration practices to make deployment part of everyone's daily work. So they were very early then with be able to deploy automatically multiple times per day. And the result of all of this, Patrick Dubois created the first DevOps days. And this is where the term DevOps was coined. So when we see the word DevOps, it's usually, or sometimes it's spelled with the big D and then the big O, because that's where it comes from. It was, as we saw in 2009, it's how could developers work with IT operations. That was the beginning of DevOps. But nowadays they want to include much more. It should be the entire IT organization, not just those two groups. So that's why nowadays people try to spell it with a small d and a small o to try to not make it be as much just developers and operations, which it can look like when it's spelled with big D and big O. So just something we can think about. So one of the fundamental concepts in Lean is the value stream, which has its origin in the manufacturing plants. A value stream is the sequence of activities an organization undertakes to deliver upon a customer request, or the sequence of activities required to design, produce, and deliver a service to a customer, including the dual flows of information and material. In manufacturing, the value stream is often easy to see and observe. It starts when a customer order is received and the raw materials are placed upon the plant floor. There's usually a relentless focus on creating a smooth and even flow of work, using techniques such as small batch sizes, reducing work in progress, preventing rework, and constantly optimizing the system towards our global goal. So we're talking about physical manufacturing plants. So this is where the Toyota manufacturing comes into place, where they observed how a big factory where they created cars. Then it's easy to see, okay, here we have a car door. It's transported from point A to point B, and when it's then assembled onto the husk of the car, and then that is moved to the next station, and so forth and so forth. So it's easy to see everything that's happening and the flow of everything. However, in technology, if we want to create our own value stream, that's much harder. So in DevOps, we can define our technology value stream as the process required to convert business hypotheses into a technology-enabled service that delivers value to the customer. And this is our lead time. So we take something, we just take an ID or a customer request, and then we should make that into a technical project or make it into code that can do something. And this can be much harder to visualize and define this whole flow. So with this problem, we need some way of visualizing this, where we take a business idea, objective, concept idea, hypothesis, and this work starts when we accept the work into development backlog work. And from there we need it to transform into user stories or feature specifications, which is then implemented into code by developers. Then the code is checked into version control software like Git, and each change is integrated and tested with the rest of the software system. So this is the part that's hard to track and visualize. Because value is only created when our services are running in production, we must ensure that we are not only delivering fast flow, but that our deployments can also be performed without causing chaos and disruption. And there are 3 key metrics in the technology value stream. We have lead time, process time, and percentage complete and accurate. So let's look at lead time and process time. Lead time starts when a request is made and ends when it is fulfilled. The process time starts only when we begin work on the customer request. It omits the time that the work is in queue waiting to be processed. So an SD is sent to us, a ticket is submitted, and then we spend a lot of time just waiting for someone to start work. Then we start work, and then we are done. So this entire thing is lead time, and then when we just work on it, that's the process time. And in DevOps, we focus on the deployment lead time. This is the time between an engineer checking a change into version control up to the change is running effectively in production, creating value for the customer and generating feedback. It focuses on this part because the process is very, very similar to lean manufacturing. It strives to be predictable and mechanistic with the goal of achieving work outputs with minimized variability. In other words, short and predictable lead times with near zero defects. So we can see the deployment pipeline just as our manufacturing plant pipeline. It should always be the same, and it should be a smooth flow. So we want to achieve deployment lead time measured in minutes instead of months. This is done by continually checking small code changes into version control, performing automated tests, and deploying it into production. And contracted to the agile way of looking before we had DevOps, then lead time was the time between we got the customer request and then until the developers were done working with it. And that's when they stopped caring. They just measured that. And then in DevOps, we want to take the next step of, okay, the developers are done with the feature or request or what it was. How long does it take for it to actually be in production and that the customer can use this new feature? So that was the history. So let's look some more again. Try to define more, okay, what is DevOps and how do we achieve it? What kind of things do we need to do at our company to work according to DevOps? So according to the book, Devops Handbook that I mentioned before, there are 3 ways, they call it, what makes something be DevOps. But as I said before, it's not something that's written in stone. So then there's also like the book Effective DevOps. This one instead talks about DevOps as 4 pillars. And that's just their view of what DevOps is. And as I said before, then it's also up to each company or IT organization to define what their kind of DevOps is. But if we take a look from the Devops Handbook, they say all DevOps principles and behaviors can be derived from the 3 ways. The first way enables fast left-to-right flow from work, from development to operations to customer. From now on, when I talk about operations, I'm not only talking about IT operations, but operations include quality assurance, InfoSec, database, and all other kinds of operations groups. So in order to maximize flow, we need to make work visible, reduce batch sizes, building quality by preventing defects from being passed downstream, and constantly optimizing goals. By speeding up flow through the technology value stream, we reduce the lead time required to fulfill internal or customer requests, especially the time required to deploy code into production environment. The resulting practice includes continuous build integration, tests, and deployment processes, creating environments on demand, limiting work in process, and building systems and organizations that are safe to change. By doing this, we increase the quality of work as well as the throughput. The second way enables fast and constant flow of feedback from right to left at all stages of the value stream. It requires that we amplify feedback to prevent problems from happening again or enable faster detection and recovery. By doing this, we create quality at the source and generate or embed knowledge where it is needed. This allows us to create safer systems of work where problems are found and fixed long before a catastrophic failure occurs. By seeing problems as they occur and swarming them until effective countermeasures are in place, we continually shorten and amplify our feedback loops, a core tenet of virtually all modern process improvement methodologies. This maximizes the opportunity for organizational learning and improvement. The third way enables the creation of a generation with trust culture and that supports the dynamic, disciplined, and scientific approach to experimentation and risk-taking, facilitating the creation of organizational learning both from our success and failures. Furthermore, by continually shortening and amplifying our feedback loops, we create safer systems of work and are better able at taking risk and perform experiments that help us learn faster. We also design our systems of work so that we can multiply the effects of our new knowledge, transforming local discoveries into global improvements, regardless of where someone performs the work. They do so with the cumulative and collective experience of everyone in the organization. So let's take a closer look at the 3 ways that make up DevOps. So, the first way. We want to optimize for the global goal of delivering value to our customer quickly with fast and smooth flow from development to operations. The goal is to decrease the amount of time required for changes to be deployed into production and increase the reliability and quality of those services. To have flow, we must first need to see it. In manufacturing, it's easy to see what is produced and when it's being transferred because it's physical parts that are moved and created. In the technology value stream, however, it's not that simple. It can be hard to see when work is impeded or when it's piling up. So to help with this, we need to visualize the work. And a good tool for this is the Kanban board or maybe Scrum board, if some people have worked with Scrum. We use these to visualize when tasks can be created and organized to create flow from left to right. And it's important that the Kanban board should represent the entire value stream. A task is not done when developers are done with it. Instead, it's only done when the new feature is in production and making our customers happy. Then we want to reduce batch sizes. Large batch sizes result in high work in progress and long lead times. We must strive to continually shrink batch sizes. With batch size, we talk about commits, features, or any work that need to be completed and sent to production. An example of the difference using large versus small batch sizing can be seen in an example of mailing 10 brochures. Each brochure requires 4 steps. We need to fold the paper, insert the paper into the envelope, seal the envelope, and then stamp the envelope. If we use large batch strategies, then we would be to finish each step with all brochures before we continue to the next step. So first we fold all the papers, then we insert all into envelopes, and so on. And if we say each operation takes 10 seconds for the 10 envelopes, it will take 310 seconds to finish all brochures. But let's say if during the sealing phase, phase 3, we discover that we made an error during the previous phase, or the first phase, the folding phase. We would first discover this after 200 seconds, and we have to refold and reinsert all papers in the batch again. So we spend a lot of time on work that we need to redo, and it takes a long time for us to realize that. However, if we instead use small batches, a single piece of flow, call it, the first brochure would be done after 30 seconds, and any possible error would be caught within those 40 seconds, and we would only need to redo that one brochure. And then we would have the knowledge from the first brochure when we continue with the second, third, fourth, and so on. And this would lead to less working time, faster lead time, faster detection of errors, and less work. And for software, the easiest batch to see is code. Every time someone checks in code, they are batching up a certain amount of work. The more traditional way of working is branch-based developments, where all the code from multiple developers are working for weeks or months. It's batched up and integrated together. So we compile we do all the brochures for all the developers, and then we take it to the next step. However, we don't want this. Instead, we want to take every little change each developer's made and test that code separately from the rest, and then try to build it together in the end. This way we can have a pipeline where we can detect errors much earlier. Next thing we want to do is in the technology value stream, where deployment time is measured in months. It's usually because there are hundreds of operations required to move code from version control into production. So to transition code includes tasks such as functional testing, integration testing, environment creation, and server administration. Each time work is passed from one team to another, it requires all sorts of communication, scheduling, deconflicting, testing, and verifying. And each of those steps are a potential cue for where work has to wait. It increases work in progress. Knowledge is also lost between handoffs, which can be a cause for failure. To mitigate these type of problems, we want to reduce number of handoffs, either by automating or reorganizing teams so they can deliver value to the customers themselves instead of constantly depending on others. So somehow we want to decrease the dependency between groups and people. Like we talked about the Etsy example, that if you're hired to do your work, you should be expected and trusted to do that. You shouldn't need to second guess it and get verification from other people. To continually reduce lead times and increase throughput, we need to continually identify our system's constraints and improve its work capacity. In Beyond the Goal by Dr. Goldratt, he states, "In any value stream, there is always a direction of flow, and there is always one and only one constraint. Any improvement not made at the constraint is an illusion." So if we improve work before the constraint, we pile up at the bottleneck, and if we improve constraint after the constraint, we got starved, waiting for work from the bottleneck. So we must always identify the biggest constraint we have in our pipeline and focus on that one. Focus anywhere else is unnecessary work. Therefore, we always continually have to work on removing constraint in our value stream and continually identify the biggest constraints and then fix it. And here we have some common constraints in the non-DevOps workplace. So we have environment creation. Deployment on demand can't be achieved if we have to wait weeks or months for production or test environments. The solution to this is to create environments that are on demand and self-service, often using virtualization. So this is a big part of where virtualization comes into DevOps. Many believe that virtualization is one of the reasons why DevOps works so well and why it has grown so much in the latest years, just as virtualization has, because they go very well together, these two. Before we needed physical servers with local access to them to restart them and build them and stuff like that. Now instead we just have the cloud where we can just type something in the web browser, and then suddenly somewhere other side of the earth there is a server ready for us to use. And then when we're done with it, we can just destroy it with the push of a button. And we can easily take our code and move it to the server. And we can use the servers to anything we want, so we can use them for more than just the production environment. We can easily set up then continuous integration pipelines and test environments and all of that. So virtualization is very important for DevOps. Then we have code deployments. So we want code to deployments to be on demand, but this can't be achieved if deployments take weeks or months. In other words, it takes 300 manual error-prone steps involving 100 engineers. So the countermeasure to this is to automate the deployments so that they are self-serviced by any developer. And this is where a lot of the configuration management tools come into play, or the infrastructure as code, or continuous integration, stuff like that. So configuration management is when everything is in code. How we set up servers, how we install and program some servers, how we create new users, how we do settings. Everything is done via code. Nothing should be done manually. That's an important step. And we can use tools like Ansible, Puppet, and Puppet Chef. And then we have the infrastructure as code that is more specific to creating and destroying cloud resources often. How we, using code, can start up a new virtual server, and how we can set up a network configuration for multiple servers so they connect to each other. And then configuration management is usually how we do stuff on the server once it's up and running. So this is also how we use tools together with virtualization, pretty much, to create good deployments on demand. And then we have test set up and run. We can either achieve short code deploys. If we can't achieve short code deploys if it takes weeks to set up test environments and data sets. And then if we have to manually run tests as well. So to fix this, we want to automate test setup and execution. So here we have more continuous integration and virtualization. So when we have pushed our code, it automatically is moved to a continuous integration pipeline. Everything is done automatically, and then we can see, did it pass or not? Then we have architecture. All of the above is hard to achieve if the system is tightly architectured, causing a code change, needing to send engineers to commit meetings to get permissions to make changes. Then it's better to have a loosely coupled architecture where changes can be done with more autonomy. So when all of these constraints have been broken, the constraints that are left are likely to be development or product owners. And because in DevOps we want small teams of developers to independently develop, test and deploy quickly and reliably, this is where we want the constraint to be. So here in the first way, that's a lot of where the cool buzzwords and tools come into play. Then like the continuous integration, the automation, the virtualization. But this is just the first of the 3 ways. So this is why I don't want to focus on the tools, because then we'll miss everything else. Now I've been talking for 45 minutes, so I'm thinking we take a 15 minutes break. So we will be back here at 20 past 2. Yeah. So stretch your legs, go get a cup of coffee or glass of water, whatever your pleasure is. And we will be back in 15 minutes. start up again in 2 minutes. So it's 20 past 2, so let's begin again. We still haven't had any questions, so I'll just continue talking. So the first way was about moving work fast from left to right. The second way is the principle that enables fast and constant feedback from right to left at all stages of the value stream. The goal is safer and more resilient systems of work, which is achieved with the fast, frequent information flow through the value stream and organization, which includes feedback and feed-forward loops. This should allow for detecting and remediating problems while they are small, cheap, and easy to fix. An important part of this is to create organizational learnings that is integrated into future work. When failure and accident occur, they are treated as opportunities for learning instead of cause for punishment and blame. All of this is extra important when we work in complex systems. In technology, most of our work happens in complex systems with a high risk of catastrophic consequences. We often discover problems only when larger failures are underway, such as massive outages or security breaches. One of the defining characteristics of complex systems is that it defies any single person's ability to see the system as a whole and understand how all the pieces fit together. Because failure is inherent and inevitable in complex systems, we must design a safe systems of work, where work can be performed without fear, confident that any errors will be detected quickly before they cause a catastrophic outcome. And we can create safer work for complex systems by meeting the following 4 conditions. Complex work is managed so that problems in design and operations are revealed, so we must see problems as they occur. Problems are swarmed and solved, resulting in construction of new knowledge. New knowledge is exploited globally through the organization, and leaders create other leaders who continually grow these types of capabilities. So the last 2 are part of the third way, and now we will talk about the first 2 conditions. The goal is to increase information flow as many areas as possible with as much clarity between cause and effect as possible. In other words, feedback and feed forward in the value stream to discover problems. In waterfall software projects, we can develop code for an entire year before we get feedback on quality from the testing phase. This is too slow for us to be able to prevent undesirable outcomes. We can use automated build, test, and integration processes to immediately detect when a change has been introduced that breaks code or the deployment process. We can utilize elementary in the system so we can see how all the components are operating in the production environment so that we can quickly detect when things aren't operating as expected. Telemetry should be radiated to the entire value stream so we can see how our changes affect other portions of the system as a whole. It's important to use the feedback loops to create organizational learnings and use that to prevent the problem from occurring again in the future. So we need systems with tools and technologies that we can use to see when things break. So here is part of it is the automated tests like continuous integration and pipelines to automatically build the production environment. And then we quickly can notice we get an alert that says, oh, the test failed. But it's also once we have it in production environments, we also have something that monitors that environment. So that is where a lot of monitoring comes into play. So we have tools like Prometheus, Grafana, Loki, what is the Elastic search things, I don't remember what they're called now. So tools that are always sending data from the production environment to somewhere where we can visualize the data and can get alerts if something happens that we aren't expecting. And once we can detect problems, we need to handle them. The goal of swarming is to contain problems before they can spread and to diagnose and treat the problems that cannot occur again. In doing so, we can build ever deeper knowledge about how to manage our system, converting inevitable ignorance into knowledge. In the Toyota manufacturing plant, every workstation has something called an add-on cord hanging above them. And when something goes wrong, anyone can pull the cord to alert the team leader and immediately work to resolve the problem. If the problem can't be resolved within a specific time, the production line is halted so the entire organization can assist with fixing the issue. So instead of working around the problem or scheduling to fix it later, the problem is swarmed and fixed immediately. To enable fast feedback in the technology value stream, we need the equivalent of the add-on cord in a swarming response. This also requires that we create a culture that makes it safe and even encourage to pull the cord when something goes wrong. When an add-on cord is triggered, we swarm to resolve the problems and prevent the introduction of new work until it has been resolved. This provides fast feedback for everyone, especially the person who pulled the cord. Preventing the introduction of new work enables techniques such as continuous integration and continuous deployment, which is single-piece flow in the technology value stream. All changes that pass our continuous build, integration test are deployed into production, and any changes that cause any test to fail trigger the add-on cord and are swarmed until resolved. So we use the manufacturing plant flow as the continuous integration and deployment process. When tests trigger fail, we halt that code change from reaching the next step in the process or pipeline. We get the notification that our test has failed, and then we can fix it, and then we reintroduce it to the continuous integration and deployment stream. And then we do that until it works. And usually we might not need to alert the product manager or owner or something like that, because usually we can fix it ourselves. But if we can't, it's important that we have the support and work environment where it's encouraged for us to lift the problem and try for us to get help without feeling ashamed for it. The effectiveness of approval processes decrease as we push decision-making further away from where the work is performed. Doing so also lower the quality and cycle time of work. This is common in top-down bureaucratic command and control systems, which become ineffective when the variance between who should do something and who is actually doing something is too large. This is also common in the following ineffective quality controls: requiring other teams to complete manual tasks that can be automated and run as needed by the team who needs the work to be done. Requiring approvals from busy people who are distant from the work process and don't have adequate knowledge. Pushing large batches of work to teams and special committees for approval and processing, and then waiting for the response. Instead, everyone in the value stream should find and fix problems in their area of control as part of their daily work. Doing this push quality, safety responsibilities and decision making to where the work is performed instead of relying on approval from a distant executive. We can use peer reviews of proposed changes to gain needed assurance that the changes will operate as designed. We automate the quality checking that is typically performed by quality assurance and InfoSec and IT operations. Instead of developers needing to request and schedule a test to be run, the test can be performed on demand, enabling developers to quickly test their own code, get feedback if the test fails, and otherwise deploy it. Doing this truly makes quality everyone's responsibility instead of being the sole responsibility of separate departments. It's impossible for the developer to learn anything when someone yells at them for something they broke 6 months ago. That's why we need to improve feedback to everyone as quickly as possible in minutes, not months. This is a big part of DevOps. Make sure that people are trusted to do the job they are hired for and not needing to be checked and second guessed in their work. So that was the second way. Now we're on to the third way. I'm just going to get my water. So the third and last way, focus on creating a culture of continual learning and experimentation. These principles enable constant individual learning, which is then turned to team and organizational learning. At workplaces where workers have little ability to integrate improvements and learning into the daily work or suggest improvements, tend to be a culture of fear and low trust. There, workers who make mistakes are punished, and those who make suggestions or point out problems are viewed as whistleblowers or troublemakers. When this occurs, leadership is actively suppressing and punishing learning and improvements. In the technology value stream, our goal is to create a high-trust culture, reinforcing that we are lifelong learners who must take risks in our daily work. We learn from our success and failures, identifying ideas that don't work and reinforce those that do. We reserve time for improvement of daily work and further accelerating to ensure learning. So let's talk a little bit about culture of fear. When catastrophic outcomes arise or problems happen in our complex systems, we don't want management to respond with name, blame and shame the person who caused the problem, or at worst punishing them. Creating a culture of fear, which makes it unlikely that problems and failure signals are ever reported in the future, leading to even more failures in the future. Dr. Ron Westrum observed the importance of organizational culture on safety and performance in the healthcare organization. He discovered that the presence of a generative culture was one of the top predictors to patient safety. He defined 3 types of culture: pathological, bureaucratic, and generative. So on the left we have the pathological organization, and those organizations are characterized by a large amount of fear and threat. People hoard information for political reasons, or they distort it to make themselves look better, and failures are often hidden. Then in the middle we have the bureaucratic organization that is characterized by rules and processes, often to help individual departments maintain their turf. Failure is processed through a system of judgment result in either punishment of justice or mercy. Then we have the one we want, the generative organization, and it is characterized by actively seeking and sharing information to better enable the organization to achieve its mission. Responsibilities are shared throughout the value stream, and failures result in reflection and genuine inquiry. Western could see that hospitals, where they wanted to learn from mistakes, were also safer places for patients. And this can also be seen in IT organizations and help us create more stable systems. So just as Westrum found in healthcare a high-trust generative culture, it's also predicted in IT and organizations' performance in technology value streams. We want to establish the foundation of a generative culture by striving to create a safe systems of work. When accident and failures occur, instead of looking for human errors, we look for ways to prevent them from happening again. And one way of doing this, which is very popular in DevOps, is to conduct the Blameless Postmortem. After every incident that gained the best after every incident to gain the best understanding of how accidents occur and agree upon what the best countermeasure is to improve the system. Okay, goodbye, meeting. So by doing this, we create organizational learning. By removing blame, you remove fear, and by removing fear, you enable honesty, and honesty enables prevention. So the blameless postmortem is something we do every time a failure, usually in production environments, occur. Then we pause all the work and all the involved people of what went wrong. They sit down. Each person has to give their view of what happened. And this is not to try and blame people or find someone that say, oh, you caused this, you are bad. Instead, the purpose of this is to try and gather as much knowledge as possible, first to understand what has happened, and then based off that, we create a plan to do something to, okay, how can we stop this from happening again? So usually, when the postmortem is done, this should result in new tests or change in some process or change in a continuous deployment pipeline. So every postmortem should have some action points at the end of, okay, with this knowledge, how can we try to prevent this from happening again? And that is a big part of DevOps, the blameless postmortems. So Mike Rofer observed in the Toyota Kata that in the absence of improvement, processes don't stay the same. Due to chaos and entropy, processes actually degrade over time. In the technology value stream, when we avoid fixing our problems, relying on daily workaround, our problems and technical debt accumulate until all we are doing is performing workarounds, trying to avoid disaster. And this is why daily improvements of work is more important than actually daily work. We do this by reserving time to pay down technical debt, fix defects, and refactor and improve problematic areas of our code and environments. We can reserve cycles in each development interval for something called Kaizenblitzen, where engineers self-organize into teams to work on fixing any problems they want. So it can make people happy if they can choose freely what they want to work on and make better. The result of this is that everyone finds and fixes problems in their area of control all the time as part of their daily work. This is something that most companies can improve, making time for improvements and fixing technical debt. So I talked a little bit through about how usually we fix this when we have time. Oh, we're too busy, we have to finish this new feature. But that just makes things worse, and we just push the eventual failure further down. Many corporations can see fixing something that already created and technical debt, they see that as a short-term loss of money because everything is short-term. Instead, we need to look long-term and see, okay, if we fix these things now, then we can eventually down the line work even faster and create better work. But that's something that's hard when everything is so short-sighted. And I think that's a lot of why corporations don't do improvement work as much as they should. We also want to have mechanisms that make it possible for new learnings and improvements discovered locally to be captured and shared globally through the entire organization. When teams or individuals have experiences that create expertise, our goal is to convert that knowledge into explicit, codified knowledge. When someone performs similar work, they should do so with the cumulative and collective experience from everyone in the organization who has done the same work before. So one way to do this is to use chat rooms and chatbots to automate, capture knowledge, and create transparency and documentation of work. Chat logs are inherently recorded and make all communication public and searchable. So by using bots in chat to activate automated processes, it becomes searchable how we do things. New hires can look through the logs to see how things are done instead of needing to ask people and look for it. People are also more apt to asking questions when they see other people doing it. The bots can be able to use for getting health checks from systems and posting status updates on commits and tests in the chat. So we share knowledge and information that is around us. Another way to spread knowledge is to encode it, create a single shared source of code repo for the entire organization, and when anything in the source code changes or is updated, it should automatically propagate to every other service that uses that library and is integrated for each team's deployment pipeline. Example of things that can be put in the repo is configuration standards, deployment tools, testing standards and tools, monitoring and analysis tools and tutorials. So we should somewhere have a gathered place where people can easily find the tools and how we do things. This all expands a lot on the configuration management and infrastructure as code that is big in DevOps. Everything should be done with code, and then our knowledge can be reflected in our code. This helps against when people quit. So production environments should not be set up manually. That should be done with configuration tools like Ansible and Terraform. And then if perhaps someone quits, we don't lose the knowledge of what that person has done so far if they do it via code. So we don't do like before when everything is done manually. Then all the knowledge of how we set up the server, how we install anything, how we start it, then that knowledge only exists in their mind. So then we are dependent on that person. This was something I ran into before I was here. When I studied, I got a side gig at the developer corporation. So I was supposed to work for 2 months at them, and I was supposed to rewrite tests, unit tests from, I think it was something like Java 5 to Java 8. We were 3 people who were hired to do this. But we only got one problem, that no one knew how to set up the test environments on our computers. So we were at that place for 2 months after our daily studies. We went to the company. Okay, let's try to run these tests. Okay, we can. Okay, let's try to find someone who can set up the test environment. And no one could help us with that for 2 months because it was all, they had some documentations for it, but it was outdated. And then some other person had some other documentation, so it wasn't even the same documentation different people had. And it was like, oh, but I think, yeah, that one guy, he did it the last time, he should know, but he doesn't remember. So we couldn't do actually any work. We got paid to sit there and wait for someone to come and help us, but they were all very busy. So most of the time we just had to wait for them to have time to come talk to us. That is very bad. That's why we want to have this centralized and things be done via code. Because then I should just be able to run that code, and then I have my environment set up. And this is why, as the people used to say, code is king. So let's talk more about leaders. Traditionally, leaders are expected to be responsible for setting objectives, allocating resources for achieving those objectives, and establishing the right combinations of incentives. They usually say leaders lead by making the right decisions. However, there is significant evidence that show greatness is not achieved by leaders making the right decision. Instead, the leader's role is to create the conditions so that their team can discover greatness in their daily work. To create greatness require both leaders and workers, each of whom is mutually dependent upon each other, and neither can solve the problems on their own. According to Guy Jim Womack, author of Gemba Walks, leaders are not close enough to work, which is required to solve problems, and the frontline workers do not have the broader organizational context or the authority to make changes outside of area of work. So leaders must elevate the value of learning and problem solving. Mike Rofer formalized this in the coaching kata. The result is to mirror the scientific method where we explicitly state our true north goals, such as sustain zero accidents, and double throughput within a year. These strategic goals then inform the creation of iterative short-term goals, which are cascaded and then executed by establishing target conditions at the value stream and work center level. For example, reduce lead time by 10% within the next 2 weeks. These target conditions frame the scientific experiment. We explicitly state the problem we are seeking to solve. our hypothesis of how our proposed countermeasures will solve it, our method for testing that hypothesis, our interpretation of the results, and our use of learning to inform the next iteration. The leaders help coach the person conducting the experiment with questions that may include: what was your last step? What happened? What did you learn? What obstacles are you working on now? What is your expected outcome? What can we check? This problem-solving approach, in which leaders help workers see and solve problems in their daily work, is at the core of the Toyota production systems, the improvement kata and high reliability organizations, aka what we want in DevOps. This is another area where many corporations can improve. Pretty much all corporations, they have their goals, they have their vision papers and stuff like that. So the president of the company and the HR department, they write some fancy paper where they say, oh, we should aim for equality at the workplace, we should be net positive on environment, and we should work together, and all those beautiful stuff. But those goals are never propagated down to the actual workers. So we only have a nice, beautiful paper that says things, but it's never taken to the workers. We don't check, okay, what have you done to work toward this goal? When do you expect to be done? What have you achieved so far towards these goals? That's where a lot of corporations also missing. They don't have that check up. Yeah, they just say something and then we ignore it, basically. And that's the 3 ways of DevOps. I'm going to talk a little more about teams, because that's also something that's very common. Okay, when someone says the word DevOps, people automatically think about tools or team structure. Also the very common picture of, we have silos, we have the developers, operations, quality assurance, and then we have a picture of people just throwing stuff over walls about that. So let's take a look about how teams in DevOps can look. On the right, we have the DevOps way of looking at teams, where we don't have one developer team, we don't have one operations, we don't have one quality assurance. Instead, we have team where we have the expertise of all of these areas in one team. And then on the left, we have the more traditional view. And this is usually how people see DevOps. But we should also know that we don't have to have these cross-functional teams to actually be DevOps. We can work according to the left side as well, but it can take more to manage that. Conway's law state, organizations which design systems are constrained to produce designs which copies the communication structure of these organizations. The larger an organization is, the less flexibility it has, and the more pronounced the phenomenon. He made an experiment where he had, I think it was 3 groups with different group setups in each group. So one group was 4 people, 1 3, and 1 was 2 people. And then each group was supposed to create a compiler. And when everything were done, they noticed that the 4 people group, they created a 4-way compiler. The 3 people group created a 3-way compiler, and the 2 people group created a 2-way compiler. So the system mirrors the structure of how we work. Eric S. Raymond conceived a simplified form of Conway's original result as: the organization of the software and the organization of the software team will be congruent, commonly stated as: if you have 4 groups working on a compiler, you get the 4-pass compiler. Having multiple compilation units, people, in the value stream, increase the number of steps source code must pass for before it reaches completion. So if you go back to the previous picture, the silos with the teams, so here we have the 3 per people team, we have the operations, quality assurance, development. So this would create the 3-way compiler. In other words, this creates 3 steps of what it takes to get code to production. So these people do something, then that is sent on to the next step. They do something, that is sent to the next step. And if we follow this Conway's law improperly, this negatively impacts our organization, production outcomes, and prevent agility. When executed properly, developers are empowered to develop, test, and deploy with independence, generating significant value for the customer. To embody DevOps best practices, we must organize our teams with certain insights in mind, and this strategy should include making the most advantage of Conway's law. So with this, we can talk about the organizational archetypes. So businesses usually fall into 3 different structures. We have the functional, where companies optimize for skill, labor division, and cost reduction. This has been the prevailing method for organizations for operations. Either we have the IT operations department, we have quality insurance, we have InfoSec. It's all about being good at your specific task and cost as little as possible. So we're good at dividing into areas, each with its specialty. And then we just send things between them instead of working together. And then we have market type, businesses who optimize for delivering value to customers at all cost. This often leads to potential redundancies across the organization, and this is how many prominent organizations adopting DevOps operate. In extreme examples, such as at Amazon or Netflix, each service team is simultaneously responsible for feature delivery and service support. This is optimized for winning market value fast. So here we have the other extreme that we have. This is the cross-functional team. We have a developer, we have the operations, we have the database guy, the quality assurance. They are all in one team. So they can do everything from developing to pushing the code to production in that team. And then we have the matrix structure, which is organizations who attempt to combine both of the above orientations. And this often results in complicated organizational structures, such as individuals reporting to 2 managers or more, which then achieves neither of the goals of functional or market-oriented. Problems that are often caused by overly functional orientation is when traditional IT teams tend to split up and organize themselves according to specialty. This has a compounding effect on the value stream by vastly reducing workflow and exacerbating long lead times. Other problems can be poor handoff coordination and an increased amount of rework, low quality results, and bottlenecks that are more widespread. Compounding the issue of the person performing the work often has little visibility or understanding of how their work is related to any value stream goals. For example, I'm just configuring the server because someone told me to. And this places workers in a creativity and motivational vacuum. So you do your little part, then you just send it away, and then you take the next. You don't get the full picture. You can't follow downstream. Okay, what happens with the things that I have created? And DevOps best practices largely advocates for optimizing for speed over optimizing for cost. So what was it called? Market over functional is what we like. And this is to improve the ability for small teams to deliver on customer value quickly. Extreme versions of such teams are the cross-functional and independent teams. These true DevOps teams are able to design and run user experiments, build and deliver new features, deploy and run the service in production, and fix many defects without manual dependencies on other teams, thus enabling them to move faster. Every team can do everything. So we skip the handoffs between teams, we skip the communication errors, everything is done within themselves. And this model is adopted by Amazon and Netflix. And Amazon says that this is one of the big reasons why they are able to grow and move so fast in everything they do, because they have grown very quickly, that company. So while I've just recommended the market-oriented teams, it's worth pointing out that it is possible to create effective, high-velocity organizations with functional-oriented teams as well. Cross-functional and market-oriented teams are one way to achieve fast flow reliability, but not the only path. In the right high-trust culture, organizations can achieve high-velocity effective workflow by enabling automated self-service platforms and promoting full transparency in work prioritization. For example, high performance with a functional-oriented and centralized operations group is possible as long as service teams get what they need from operations reliably and quickly, ideally on demand, and vice versa. Many of the most admired DevOps organizations, such as Etsy, Google, and GitHub, they still work according to the functional organization. They have IT operations, they have developers, they have quality assurance. They still have the split up, they don't mash them together. So in this picture, on the left, we have the functional teams. So we have the different developer teams, and then here we have the different operations teams. So we have server test, network teams, database, virtual machines, and here we can see the path of how everything goes when new features are sent to the next team, the next team. And this we don't want. Instead, if we want to continue to use the functional teams, organizations, we can see on the right instead that they should provide services and platforms for the developers to use so they can themselves take their changes into production. And this is where something many people have a hard time grasping when they are introduced to the to DevOps. How we can achieve this, and that operations they're supposed to help the developers by giving them access to things and not do the work for them instead. High-performing DevOps teams have one shared trait. The whole team shares a common goal, the goal of making quality, availability, and security a part of everyone's job every day. Jody Malky, as a CTO at Ticketmaster, highlights this in his theory of the DevOps with an American football metaphor. Operations are the offensive linemen, developers are the skill positions like quarterbacks and wide receivers, whose job it is to move the ball down the field. The job of operations is to make sure that developers has enough time to properly execute the play. Everyone works together as quickly as possible to move things into production. Overspecialization, at extreme consequence of functional orientation, can cause silosation. So when team members are isolated in their contributions to the value stream and have no alignment with others. We rely upon an ever-increasing number of technologies. We must have engineers who are specialized and achieve mastery in the technology areas as we need. However, we don't want to create specialists who are frozen in time, only understanding and able to contribute to the one area in the value stream. So to counter this, we want to encourage people to become generalists by providing varied opportunities for skill development, encourage a growth mindset in organization, and hire for generalist skills. By cross-training and growing engineer skills, generalists can do orders of magnitude more work than their specialist counterparts, and it also improves our overall flow of work by removing queues at wait time. So we want to encourage the people get more knowledge in other areas than what they work with, to then prevent the silos between areas. So if we look at the picture, on the left we have what we want to avoid, the I-shaped specialist. They are skilled in one area but tends to cause bottlenecks. Instead we want the T-shaped in the middle, which has more broad knowledge. So they're still quite expertise in something, but they have more knowledge about other things as well. And what we want to achieve is the E-shaped specialist, that are knowledgeable in many areas and expertise in many areas. They don't have to be as good as one thing, but they have more knowledge about many things. So what the big thing we want to avoid is something what many people talk about, rock stars, where we have one person who is the best at something, so only he does that thing. And this comes back to the codified thing as well, that we don't want all the knowledge of something being in one person's mind. So let's say we have a part of our system that one guy, he's always the one developing new features for that part of the system. And when every time something goes wrong in that part of the system, everything is just sent to that guy. So what do we do if that guy wants to go on vacation? Okay, and then something goes wrong in that part of the system. Then we have to get that guy back from the vacation and to fix that thing. Or what if he quits? And we have the same problem. Then we have a whole part of our system that no one understands and no one can do coding because only one guy knew that. So that's why we want people to be experienced and knowledgeable in all areas of what they work around. So making development work more visible to IT operations and vice versa is the keys to establishing the DevOps culture and managing different teams. There are 3 broad strategies which can accomplish this. We can empower developers to become more productive by creating self-service proficiencies. We integrate operations engineers into service teams and encourage collaboration. We include ops engineers with all daily dev work from inception to production conclusion. And to achieve those 3 strategies, we can do the following. And now when I'm talking about operations, it's not only IT, it's the quality, info, and database, network, and all that as well. So we can create a shared service to decrease developer productivity, which means to get operations to build platforms and services which will boost development efficiency, encouraging the creation of DevOps tool optimized for internal customers, reduce operations becoming bottlenecks in the value stream, and enables the realization of market-oriented goals. This should create tools and platforms the developers use to move their code into production. And then we have embed ops engineers into our service teams, which means to integrate operations into dev teams early on is fundamental to fostering closer interactions on production responsibilities. On top of that, merging the two connects operations to service delivery and support and promotes cross-skills training. We can do this by assigning an ops liaison to each service team. So if it's not possible to embed an engineer within a service team, delegate an operations liaison to coordinate with the team directly. This will motivate dev and operations to collaborate better at all project stages. We can also integrate operations into dev rituals. With the ops engineers and liaisons working closely with dev teams, it's important to ensure that they get involved with all existing development cultures and practices. This way, operations can better plan and influence work early on and pre-production. Then we have invite operations to our dev stand-ups. So one of these rituals is the Scrum Daily stand-up, where everyone shares that work, what is completed yesterday, what is to be done that day, and what is preventing them from moving forward. With operations present to listen to devs describe this, they can glean valuable information which may affect their own activities. The second to last one, invite operations to dev retrospectives. So just as crucial as the daily stand-up is ensuring that operations can attend dev retrospectives at the end of each development interval. This agile practice encourages review of past tasks, promotes feedback and improvement for future work, and promotes organizational learnings within teams. We can make relevant ops work visible via on-shared Kanban boards. As established in the 3 ways principle, visualization of work between dev and operations is an integral component for improvement workflow. This does not simply mean that devs share their work. It is vital to highlight relevant operation activities. Kanban boards are an excellent team management tool to achieve this. Implementing this strategy can help prevent operation crises in production and reduce blockage on product delivery. And that was the end. This is one view of DevOps, the more theoretical and workplace view of what it is. So I said before I didn't want to focus on the tools, but more of the idea and what it means to work at the corporation that works according to DevOps. As I said before, this is largely based on the book, the Devops Handbook. And then instead of on different view, we can read the effective DevOps, which view it as 4 pillars. I can also recommend the book The Phoenix Project, which is more of a literature book. Like we follow a guy who works at a corporation, and then we have to follow his journey of making the company work towards a DevOps workplace. So more of in you can view how it works to go from, I think they worked waterfall and then eventually worked according to DevOps to fix the corporate issues and actually managing to turn a profit. But the other two are more factual books. Do I have any questions? Not many viewers left. One thing I can say also that many people has a problem with DevOps. They say, oh, but I'm a developer, but I don't, DevOps is only for websites and new startups. It doesn't work for embedded systems. It doesn't work for creating platforms. It doesn't work for creating tools and so forth. But that, again, we come to the DevOps isn't something set in stone and saying you have to do all of these things. You have to do it exactly this way. With production environments, we always mean it's a server that is up and running 24/7 for people to access. That's not what it is. Instead, it's about you can take these concepts and try to apply them to your company. So if you work with embedded systems, that software usually runs on many machines out in a warehouse or something, perhaps. So then maybe we can't see the end result as the production environment. We can't see that as the end goal to get it up and running on the machines in the warehouse. Instead, the end goal is having code or software ready to easily be in an artifact repository. So we just simply can take the code from there and then move it to the machines manually. So we have to always check what does our company do and how can we apply DevOps idea and concepts to what we do, and not say how do we change our work according to DevOps. Yeah, I haven't gotten any questions, so I think I'll end the stream here. So thank you for watching, and I think it was Wednesday, you'll hear from Igor, and he will talk more about the tools and that stuff, and we can see more how we can apply DevOps to some more practical work. Yeah, so thank you for listening, and goodbye.